Hey you guys, it's Ms. Smith here. We have gotten to our graphing test review. So in the test review video, I'm going to go over every single problem, which means this is going to be a longer video. Please feel free to fast forward as much as you need to make this video serve you best, okay? So the information is all here and you just access it in the order that it works best for you. Let's get started. So, number one, y equals 4x plus 3. Now, if you remember your slope-intercept form, you can sketch the graph based on that. But what if you don't remember your slope-intercept form? Well, I'm going to also show you how to make a table. But if you know your slope-intercept form, this is your y-intercept. It's the number without the x, and you would put a dot right there. And then the slope is the number with the x. Now you need a rise and a run, so don't think of it just as a 4, think of it as a 4 over 1. And so you would go up 4 over 1. Well, oh gee whiz, that went off the graph. So maybe I should go down 4 and to the left 1. And so I would put another dot there. So that works that way if you want to just draw the line that way. But what if you need to make a table? Or what if your teacher says you have to make a table? Then you can make an XY table. I'm going to use the following x values. I'm going to do -4, -2, 0, 2, 4, okay? And that way I have a nice spread across the middle of my graph. Different teachers might use different values. This is just the way that I like to show it done. And now we're going to plug each one of the x values into this equation, and we're going to plug it in for x because those are x values. So grab your handy calculator, and you've got 4 times, let's start with this one first, -4 plus 3, and that equals -13. -13. Maybe I didn't choose the best values because that's going to be off the graph. Let's keep going. Let's see what we get for -2. So for -2, we get 4 times -2 plus 3 equals -5. -5. That works just great. I think this is going to be okay. Now let's plug in 0. 4 times 0 plus 3 equals 3. Let's plug in 2. 4 times 2 plus 3 equals 11. 11? Okay, that one's going to be off the graph also. So if this one is off the graph, I know the next one's going to be off the graph. 4 times 4 plus 3 is 19. So that's not super helpful. You know what I'm going to do? I'm going to add a value of 1 right here so that I get a little bit more information without it going off the graph. So 4 times 1 plus 3 gives me 7. That I can almost fit onto my graph. Okay, so these aren't going to fit, which is fine, no worries. This one's not going to fit. Let's do these 3 points. So -2, -5, boom. 0, 3, I already have that from when I looked at the slope-intercept form. But if I didn't remember how to do slope-intercept form, I wouldn't have it yet. So I'd have this, and then I'd have this, and then 1, 7 will be right about there. And if I had done a -1, I know from this graph that it would be -1 here also. Okay, so sometimes you need to adjust to make it fit with what you're dealing with, and then you connect your line. Let's go on to the next problem. Number 2, y equals -x plus 1. Okay, if you're just using slope-intercept form, start with your y-intercept. Y-intercept is the number without the x. So this guy's all by himself. That's my y-intercept. I'll put a dot there at 1. Now what's my slope? My slope is the number in front of the x. And in front of the x, I don't actually see a number. I just see a negative sign. So if there's no number there, you know it's a 1. Since there's a negative there, I know it's going to be a -1. And we also need a rise over run, so I'll make it -1 over 1. So when it's a negative slope, it's going to go downhill. Make sure it goes downhill. You're going to go down 1 over 1, down 1 over 1, down 1 over 1. You could also go up and to the left. So it's going to look kind of like this. Now, if you wanted to make your table of values, I'll let you choose. Do you want to do -4, -2, 0, 2, 4? You could also do -2, -1, 0, 1, 2. I think that's very valid as well. On this graph, that would have worked better. But I'm going to stick with my original plan over here, just because I want to for this time. And I forgot to show you on a different calculator, so I'll show you now. If you're at home, you might need to use the Desmos Scientific Calculator. So you go there, you're going to enter your equation. Don't do the y equals, just do negative, and then we're going to have a -4 plus 1. And then the answer shows up over here. So it looks like that's going to be a 5. Okay. And remember, because there was a negative in the equation, I started with that, and then there was a negative on the 4, so that's why I wound up with 2 negatives. Okay, now let's change the x value to a -2. So I have a negative 2 plus 1 gives me 3. Now let's change the x value to a 0. -0. There's no such thing as -0, so it's just going to be like that. And then now I need to change it to a 2, so -2 plus 1 is -1. And now change it to a 4. -4 plus 1 is -3. Okay, now I have all my values. I can put them on the graph, except they're kind of already there. -4, 5, -2, 3, 0, 1, 2, -1, and 4, -3. And they all line up with what I thought when I was using slope-intercept form, so that's always nice, and that's what your graph looks like. Okay, let's keep going. Now these graphs are different. Why are they different? Well, are they still in slope-intercept form? No, they're not. Now we have some exponents to look at, so that's kind of cool. Let's definitely do -4, -2, 0, 2, and 4 this time. Those values work a little better when you have exponential functions. Okay, let's plug them in. So starting with this calculator, again, you don't need to put the y equals in. And what you do need to do is just replace the x with one of these values. So we'll do 3 times 2 to the power of, so I'll use this button right here. And let's start with -4. And then we still have +2. Don't forget the +2 at the end. A lot of times that little guy gets forgotten. Now 35/16, that sounds like a pain to graph to me. It's just harder to think about fractions sometimes. So I'm going to convert it to a decimal with my convert button. And I'm going to get 2.2. Okay, now let's do -2. So we'll do 3 times 2 to the power of -2, bring it down, and now +2. And I'm going to get 11/4, which is the same thing as 2.8. Okay, and now I'll show you on the other calculator if you want to see the Desmos Scientific calculator. Looks like this on your phone. Would look a little different on your computer, but not very different. 3 times 2 to the power of. For the power of, you're going to use this A to the B button, okay? So to the power of 0, because that's our next x value that we want. And I'm going to bring it down, +2. Equals, oh, sorry, I didn't even need to push that, equals 5. Okay, now I'm going to change my exponent from a 0 to a 2. And it looks like now it's going to equal 14. And then if I change that to our final value of 4, what's it going to be? 50. Okay, and then we're just going to graph it. So let's see what we get. This is the fun part. -4 and 2.2 will be right about there. -2 and 2.8 will be about there. 0, 5, 2, 14, 4, 50. Wait, no, 50 is not going to fit on the graph, and that's fine. A lot of times they don't, especially with these exponential things. So look at the 4 dots that we do have. It looks like it flattens out right here above the 2. So that's going to be our asymptote. Make sure it flattens out and it doesn't go below that point of 2, that line of y equals 2, and then it goes very much up from there. And that is your exponential function there. Nice little curve. Let's do number 4. Same idea, different equation, make your xy table. -4, -2, 0, 2, 4. Okay, calculator, we're going to plug different values in for x. Start with the -3 times parentheses 1/2. Close those parentheses up, do your exponent button, start with -4. Bring your cursor back down and you do -2 at the end. Okay, that all looks good. I'm going to hit enter and I'm going to get -50. Okay, -50, that's fun. And now we're going to do the same thing but with -2. This time I will show you on the Desmos calculator. Let's erase what was there before. And we're going to start with -3 again. -3 times parentheses. For 1/2, just do 1 divided by 2. And then close your parentheses. A to the B for the exponent, and this time our exponent is going to be a -2. And then make sure you bring your cursor back down by touching the screen, okay, before you do your -2. And it looks like what we get there is negative 14. All right, now I'm just going to keep on changing that exponent because that's the value of x. And I'll put 0 there for now. And then I get negative 5. And then I'll put 2 there, and I'll get negative 2.75. I'll just put negative 2.8. And then I'll put 4 there for negative 2.2. Negative 2.2. Okay. So there we go. Now the fun part, we get to graph. It looks like it's all below the x-axis. Remember, the x-axis is way up high. You just have to look for it sometimes. Here it was down low. So negative 4, negative 50. Oh, that's not going to fit on there. So let's move to the next one. Negative 2, negative 14. There we go. 0, negative 5 will be here. 2, negative 2.8 will be about right here. And 4, negative 2.2 will be about right there. I feel like that was, it's not quite. Did I put this in the wrong place? I did. That's why it looks funny. 0, negative 5 should go here. So my bad if you caught my mistake. Good work. And now we make our graph. And it's going to flatten out completely right at about negative 2. Okay, so your graph shouldn't veer above the line y equals negative 2. And that's what it looks like. Any questions? And I guess I can't really answer them, but you can definitely ask your teachers, okay? We love to help you. Let's do some word problems. A savings account balance is compounded annually. If the interest rate is 2% per year and the current balance is $1,986, what will the balance be 10 years from now? So this is where you need your growth and decay formulas, okay? So is this growth or is it decay? Let's see. You have a savings account and you're earning interest, so that's going to be growth because your amount of money is growing. Fortunately, you don't want it to decay, right? You want it to grow in the bank. Remember that A is your initial amount. That's your starting amount, so 1,986 right there. R is your rate. It's usually going to be some kind of percent. In this case, 2%. 2% transferred into a decimal is going to be 0.02. Make sure when you put this into your equation, you always use the decimal form of it. If you're unsure about how to move your decimal, you can always do this percent number divided by 100. And that's what percent literally means, per 100. So 2 divided by 100 will give you the same thing. Okay, and now if you're just solving the question, what would you put for time? You'd put 10 years. But when we're making a table, you want to use all kinds of different numbers. You're going to use 1 year, 2 years, 3 years, 4 years. So we're going to just leave the time like that. Let's go ahead and make our equation. Make sure you use the right formula. Y equals 1986 for the amount, parentheses 1 plus what was the rate, 0.02. And then to the exponent of, well, let's just say t because we're going to change it all the time. And then I'm going to make my table. I'm going to list it out 0 through 10. 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these are the number of years. This is the time, and that's going to also be my x values. I'll put my y values over here on the other side, okay? And the y values will represent the account balance after that amount of time. So let's put it in the calculator. Don't need to put the y equals in. Start with that 1986. And then parentheses 1 plus 0.02. And then, you know what? The first value in our table is 0. You don't need to put that in here because that's the starting amount. After 0 years have passed, well, it's just your starting amount. So you know it's going to be 1986. But you do need to put it in for the 1. So let's go ahead and skip to the 1. Do your exponent button, and we'll do x equals 1. 2025.72. This is money, so let's keep our dollars and cents. 2025.72. There we go. Now after 2 years, you would do the same thing, but you would put a 2 up here. I'm going to do it on my Desmos so that you can see it both ways. Let's see. Here we go. Where's my formula? 1986, parentheses, 1 plus 0.02. Close those parentheses up. And then the exponent is going to be, in this case, a 2. 2066.23. Okay, I'm going to put this over here so I can write a little better. Now let's make the exponent into a 3. We get 2107.56 when we round it. Let's make the exponent into a 4. 2149.71. And let's make it into a 5. 2192.7. Oh, did I? Oh, yeah, it's 0.70. Okay. And let's make it into a 6. 2236.56. Let's make it into a 7. 2281.29. Make it into an 8. 2326.92. We're rounding there. Make it into a 9. 2373.45. And then finally, if the exponent is a 10, it's going to be 2420.92. So if you left that much money in your savings account for 10 years at a 2% interest rate compounded annually, you would wind up with this much money. Okay, and now let's just put that on the graph. So the answer to the question is this number right here, and then the graph is going to look like this. Looks like we're counting by 200s here, so 0, 1986 is going to be about right there. And we're only going to go up from there. 0, 20, 25 will be, say, there. 2066 will be right there. I'm keeping in mind that this line represents 2200, so I am pretty far from that still. 3 is 2107, so it's going to be about halfway there. 4, 2149, 3/4 of the way there. 5, 2192, still not past that line. And 6, 2236, so finally I can pass that line just by a little bit. 7, 2281, goes about right there. 8, 2326, just a little bit over the halfway point there. 9, 2373. And 10, 2420. So your line will kind of go like that. Now, it should be a curved line, right? Because this is an exponential function. But when your rate is such a low percentage, you're not going to see the curve over this small amount of data. If you did 100 years, you would see it curve up. But with just 10 years, I mean, you can barely see it. Okay, let's go on to, actually, hang on one second. Okay, yeah, really quick. Looking at the next 3 problems, I'm not going to do the next 3 for you, but they all work the same way. The only thing that could be different is whether it's growth or decay. So for example, if a country is pledging to reduce its annual carbon dioxide emissions by 5% per year, if you see a word like reduce, that's going to be decay. So be sure to use the formula that has the minus in it. And then over here on the last page, the philanthropist is pledging to donate 16% of a fund each year. If the fund initially has this much money, how much will the fund have after 5 years? So he's donating 16% of this fund that he has. So if he's donating money from it, the money's getting smaller and smaller. It's getting less and less. So that's going to be a decay. So make sure you use this formula with the minus in it. And then over here, an employee is receiving a 3% raise once per year. So if he's getting a raise, is his salary growing or shrinking? It's probably growing. That's what we want our salaries to do. So you would use the equation with a plus in it. Okay, you guys, if you have any questions, ask your teachers. We are here to help you, and we love helping you. And I hope you have an awesome day. Bye.